Welcome back to my YouTube channel. Please like, subscribe and share my videos to your friends and families. Let's learn together. Welcome. Today I'm going to talk about the switch gears or apparatus which we use in our electrical field, such as relays, contactors, switches, different kind of the apparatus or different kind of the switch gears. Welcome and let's learn together. Welcome to my YouTube channel. Previously, in the previous video, I shared about the switch gears, some of it. Today I'm going to share more about it, and maybe you'll learn more and a different switch gear from the ones which I talked about last time, and also the controllers. So welcome. Please watch my videos till the end and keep watching. Support me by subscribing, like, comment and share. Share it to your friends, family, and as you support me, I will keep on sharing more things and we will keep on learning. Welcome and let's watch together and learn together.
This is the current transformer. This one is for power factor relay. This one for kilowatt. This one for ammeter. And this one are our fuses. To detect if there is a problem. Once there is a problem, we check for our fuses so that they protect the breaker.
As you can see here down, you can do settings through this. You can adjust this one, then this one, then this one. You can adjust the setting. The tripping setting is this one. If you want to set the tripping, then this one, the center one is 50% setting, and this one is when the neutral and phase come across setting. For this one is set as at 50%, as you can see, and the tripping point is at 5.5 amperes. That is the setting at the center, and this one is set as tripping point. It can trip as when it senses the ground having 0.04, that is milliamperes. That is the sense setting. Then here we have a reset switch. As you can see, this is a reset switch. This is a test switch. So you connect here the tester, then you press this one. It will show all the settings inside the isolator. Mainly this one is rated at 400 amperes, but the settings are here. For this one it's set at 50%, so meaning it's 200. If it exceeds more than that, it can go off. Then it has 100% and it has 50%. Then when it trips, it will come here. This is when it is on, and here it is when it is off. From there we find these ones are called MCCB. This one, modded case circuit breaker. The work of this is to trip when there is any overcurrent or there is a short circuit. Automatically this one will go off, mainly for short circuit. it will trip.
Yes, yes, have a little.
This one will this breaker. I think one more photo. Yeah, need to check one. This one comes from the fabric. Even myself. Yes. So this one is I mentioned. I reply they are no with that circuit board. Yeah, they're saying no circuit board. This giving this photo. After they're asking for LPA like that. Yeah. No control module, not this one.
This is the same with the isolator. It's isolator, this one. Its work is the same with the other isolator. As I told you, the work of isolator is to switch on and off the power. So this one switches on and off. It is just the same. You pull it up, it is on. When you pull down like this, it is off. So this is how to switch it on. You switch like this. Now it's on. The machine is running. This one we call it thermostat. The work of thermostat is to check and control. This is thermostat controller. Control the air. What you set here, it's what you will see. The temperature will change. Another type of isolator, whereby this one, as the arrow shows you, when it is here it's on, and when you switch it to here it's off. So this is also another type of isolator, meaning when you go to the field there is different isolator, and also the model and how it is made is different. But as I told you before, isolator, the work of isolator is just switching on and off, and that's all. Isolator cannot trip. Its work is only to isolate the power, to switch off the power. And although some isolator are more advanced such that they are connected how they can trip also, but this kind of isolator cannot trip in any way unless you switch it off. It cannot prevent short circuit or high current consumption. So for this one, it's only just like a switch on and off. This one we call it PMCB, MPCB. MPCB, the work of MPCB is motor protection circuit breaker, whereby these cables are connected inside the motor. If the motor has any problem, overheating or any other problem, it will detect and automatically it will switch off the power by tripping. You can set here, you can see this switch, it's for setting the current which you want. Then if it goes above the current, it will automatically trip. As you can see this arrow means with this star, it means that it can work in auto. So its work is to protect the motor. That's why it's called motor protection circuit breaker. It's fed from another circuit whereby it's sensing the overcurrent or road current. So it's connected with this one we call it thyristor. If for example it is consuming a lot of voltage, these cables are connected to the output. There is input and output. As you can see, there are two cables each, one cable input, one cable output, each phase. So this phases goes output goes to the goes out to also these cables. The output of this one goes to the VFD. That one we call it variance frequency drive, whereby after from variance frequency drive, then it goes to the MPCB. After MPCB, it goes to the motor. So the work of this thyristor is to monitor and also to, when the motor has overheating, automatically it will send signal to the VFD. This is the VFD. The full of VFD is variance frequency drive. Variance frequency drive. So its work is to drive the motor. The work of thyristor is to take to check the motor when it has a high current rating or it is getting hot. It's a thermostat. It has a thermostat inside. So it will automatically send the signal. Then after that, because of the heating, it will send the signal. It will show that it's overheating. Automatically it will go off. A type of isolator, as you can see. This isolator, it has different phases. This one is for the motor control, and it is connected. It is just one, but this one is for controlling motor. Instead of using contactor, this is what now we use for high voltage, for high current, not high voltage but high current. So this one, if you switch it on or off, automatically, as you can see the setting inside, it's a switch, but it is having 6 phases. I mean, it is 3 phase, whereby these two cables comes from the motor and 2 cables comes from the main, whereby you see 6 cables and there up is 6 cables. So input, there is 6 cables and output 6 cables, whereby our motor connection is here in there. It's a delta star, whereby this switch works for it like that. It's connected as a delta star. So instead of using contactor, you use this one because it's more safer, and also it works as a it has a very high tripping point. So if the motor has any problem, it will detect and it will go off automatically also. It's like a breaker, so it will break if it has a lot of consumption. It's a different from contactor, so this one can break if it exceeds the set point. As you can see, these 2 cables, as you know, the motor inside we have 6 contacts, whereby each coil has 2 contacts and it's 3 coils, so 6 contacts, whereby we have these 2 cables, which now we got it in the control. These are the motor contactor. You can see these motor contactors are more bigger. So this motor contactor is connected to that main switch that I have showed you. So the output of this contactor is connected to that isolator, whereby the isolator isolates 6 cables as it is given to the from the control circuits, whereby after the power flows from the contactor, it goes to our isolator. Our isolator is different from the isolator that you are used to see, which isolate only 3 cables. This one, for the motor, it isolates 6 cables, whereby it is from the delta and star delta. As you can see, each contactor is for 1. We have the main power, we have the star and the delta. So it works like that. As you can see, 3 contactor for 1 motor, 3 contactor for 1 motor, 3 contactor for 1 motor, 3 contactor for 1 motor. Then from there we have this one. This one is ELCB or ELR. That is earth leakage relay, earth leakage relay, or earth leakage circuit breaker. Now this one works as when there is any fault for grounding, for ground, it will send the signal to this contactor. Then from it will send the signal to this small relay. Then this small relay are the one which are controlling these contactors. So after it send the signal, this contactor will automatically go off because it will cut the power supplied to the coil of this contactor. So this is the work of the ELR, or earth leakage relay. Earth leakage relay. That is the work of the earth leakage relay. From there we have this one. This one we call it UVR, under voltage relay. When the voltage goes down, this one will sense and it will send the signal, because also it's connected to the motor. It will send the signal to the main, this isolator. This isolator is connected to it, so it will send the command here, and automatic this one will go off, because this one it's auto. This isolator is connected to auto. So from under relay, when the voltage goes down from 240 to 180, automatically it will switch off. If it goes from 415 or 420 to down to 380, automatically it will send the command and it will switch off the whole circuit. So that's how this UVR works, under voltage relay. We have different these relays. We have under current relay, but this one is under voltage relay. We have also another one which is under voltage relay. This one, as I told you, is ELR, meaning earth leakage relay. Its work is to sense any earth leakage, and it will sense very high. As you can see the setting here, the setting is at 0.06 milliamperes. So with a small current, it will sense and it will automatically go off. That's the work of under ELR, that is earth leakage relay. And the work of this one, under voltage relay, it's when we don't have enough power, then automatically it will sense. So you know the difference of under voltage relay. From the previous video, I talked about under current relay, but this one is a different one. This one is under voltage relay. The principle is different, the principle is the same, but the only thing is that this one goes with the voltage, the other one goes with the current. It checks the voltage, the other one checks the current. That is the difference of under voltage relay and under current relay. That is the difference. The work of this relay is to control these contactors, all to make it function. This relay are the ones which are powering these contactors. So the work of relay is to control the big circuit, while a relay is only needed very low current or very low voltage to control big controllers, such that this is a motor contactor, meaning the contactor, it has a lot of power output, while this relay, it has only small current related, whereby it cannot control the motor because of the principle of its work. The work of a relay is to control the contactors. Then here we have this one, we call it thermostat. This thermostat controls the motor. Also it senses the motor when it has overheating. It will send the signal and it will switch off the contactor because it's connected to the contactor. If there is any more load or a lot of current is being consumed, automatically it will send the signal and it will go off. So that is the work of the thermostat. As you can see here, there is setting, and this button is for reset, and this button here, red button, is for stop. If you want to stop emergency, you push it. If you push this button, automatically it will go off. This one is for resetting. If it has a problem, the motor it has gone off, then you will come here and push it in, then automatically the contactor will connect again after you have resolved the problem. Then we have these buttons. This one is for setting the current that you want. You send the triple set with this one, because this one is more accurate. That's why it has a thermostat, and also it has also another kind of a thermostat whereby it's by setting the kind of current that you want to go through the contactor. So you set here, then it will be okay. As you can see, these cables are connected to this relays, and also it gives the command to the contactor to have operation. So all these things are connected to each other to work in the same manner. That's why you see this cable is connected to this cable. It comes from there. So it gives the command, this one. When it gives the contactor command, then it will change to control the circuit to work how it is supposed to be. As you can see, this contactor is already connected, meaning the motor is working, and and also this one is connected. So the motor is running in a delta. This one is off, so it's not in star, it's a delta. So that's how today about switch gear. Those are the switch gears which we will learn more about the switch gears.